In this video, we're going to look at inverse trigonometric functions. We're going to start with y equals sine x, and we're going to take the inverse of the function. When we find the inverse of the function, we switch the x and the y values. 0, 0 would stay at 0, 0. Pi 0 would go to 0 pi. 2 pi 0 would go to 0, 2 pi. And we'd end up with a graph that would look like that. And that is not a function. So when you have a function, you're only allowed one y value for every x value. So we need to restrict the domain of sine x so that when we find the inverse, there's only ever one value for each x. So if we want to pass the vertical line test for the inverse, we have to pass the horizontal line test for the original. We need to have all the positive y values and all the negative y values. So we're going to choose the interval from minus pi over 2 to pi over 2. We can now find the inverse of sine x. So take these values and swap the x and y values. Minus pi over 2 minus 1 becomes 1 minus pi over 2. 0, 0 stays at 0, 0. Pi over 2, 1 becomes 1 pi over 2. When you graph those points, this is the picture you'll get. Minus 1 minus pi over 2, 0, 0, 1 pi over 2. If you're wondering about the exact shape of it, that comes from taking a few more points. At pi over 6, the sine value is a half. So at a half, we're at pi over 6. At pi over 3, the sine is root 3 over 2. So at root 3 over 2, we're at pi over 3. What we're going to do with that is evaluate some inverse sine values. If you're asked to find the inverse sine of root 3 over 2, what I'm asking you to do is tell me what angle has a sine value of root 3 over 2. So sine is y over r. This is a triangle we're familiar with. It's the 1 root 3, 2 triangle. And the angle across from root 3 is the bigger of those two angles. So that would be pi over 3. Now you might be looking at this and saying, isn't this exactly what we did in 12b? And it's very, very similar. The difference between what we did then and what we're doing now is you're only allowed one answer. The reason you're only allowed one answer is this is a function. When you evaluate a function, it is allowed one answer, and the answers for sine must be between minus pi over 2 and pi over 2. And you might be asking, why are we doing this now? What does it have to do with implicit differentiation? We are eventually going to take the derivative of these functions, and we haven't worked with them in a while. So we're going to remember how to work with them before we take the derivatives. The arc sine of 1/2. The arc sine is asking for the arc whose sine value is a half. That's another way of saying what angle has a sine value of a half. Sine y over r, that angle, it's the same triangle we worked with a minute ago, but it's the smaller angle that we're looking for. So that angle is pi over 6. So what's the difference between arc sine and inverse sine? Nothing. It's just a different notation. So when you see arc sine, inverse sine, they mean the same thing. What angle has a sine of the given value? Inverse sine of 1. What angle has a sine of 1? You're going to draw the circle for that, and you're looking for where on the circle does y equal 1. Y equals 1 when your angle is at 90 degrees, which is the same as pi over 2. Arc sine of 0. What angle produces a sine of 0? In other words, where on the unit circle does y equal 0? It's 0 degrees, or 0 radians. The last one, let's find the inverse sine of the sine of pi over 4. It's a little more complicated. We always work from the inside out, so we'll start by finding the sine of pi over 4. There's our triangle. With pi over 4, the sides are 1, 1, and root 2. So the sine of pi over 4 is 1 over root 2. And now we're finding the angle that has a sine value of 1 over root 2. Well, that's pi over 4. There must be a quicker way of doing that. We started with pi over 4, we went to 1 over root 2, and then we went back to pi over 4. The reason we're doing that, inverse sine and sine. Sine takes you from pi over 4 to 1 over root 2. Inverse sine takes you back. They essentially undo each other. Will this work all the time? The answer is almost. So if you're looking for a quicker way of doing these, inverse sine undoes the work of sine, sine undoes the work of inverse sine. Getting from here to pi over 4 will work most of the time. I'm going to show you later when it doesn't work. Let's try cosine. The original graph of cosine looks like this. We have the same problem finding the inverse as we did before. The original does not pass the horizontal line test. So when we try and switch x and y values, it will not pass the vertical line test. So we need to restrict the domain again. We're looking for all the positive y values and all the negative y values, but we only include them once. So we're going to choose the interval from 0 to pi, and now we're going to find the inverse. Find some key points and swap the x and y. 0, 1 will become 1, 0. Pi over 2, 0 will become 0 pi over 2. And pi negative 1 will become negative 1 pi. There's our negative 1 pi, 0 pi over 2, and 1, 0. If you're looking for a couple of other points, at pi over 6, we're at root 3 over 2. So somewhere around root 3 over 2 is a pi over 6. And at pi over 3, we're at a half. 1/2 pi over 3. The shape is not all that important. I just want you to get an idea of what's happening. And this is what really matters. We're going to try and evaluate these. Having seen what we did with sine, you go ahead and try them first. Put me on pause, and then we'll check your answers. Checking your answers. Find the angle that has a cosine of root 3 over 2. Cosine is x over r. That's our 30, 60, 90 triangle. The angle across from 1 is the smaller of the 30 and 60. It was pi over 6. Arc cosine of a half. What angle has a cosine of a half? Cosine x over r. Again, our 30, 60, 90 triangle. This time we're across from the bigger side, so it's the bigger of the two angles, pi over 3. The angle whose cosine is 1. We'll need to draw the unit circle. Cosine x over r. Where on the unit circle does x equal 1? That's 0. The arc cosine of 0. Again, draw the unit circle. Cosine x over r. Where does x equal 0? Our answer for that, pi over 2. Now, if you're having a moment here and saying, there's two places where x equals 0, why are we only answering it once? Remember, this is a function. You're allowed one answer only. And when we found the domain of the inverse cosine graph, we said it can only go from 0 to pi. So yes, this answer works if you're finding out what angles have a cosine of 0, but this is the only answer we're looking for when we're finding the arc cos of 0. What angle has a cosine of negative root 3 over 2? Cosine is x over r. There's our 30, 60, 90 triangle again. The angle across from 1 will be pi over 6, but we want this angle. How far is it? Starting at 0, going all the way to here, and only leaving pi over 6 away from 2 pi. That would be 5 pi over 6. The inverse cos of the sine of pi over 4. Be careful about just canceling those out. These are not the same. So we can't just undo one. We'll have to work through it. Sine of pi over 4, sine is y over r. So we're finding the inverse cosine of 1 over root 2. What angle has a ratio of 1 over root 2 is pi over 4. Are you sure we can't do that? And the answer is yes. There are a few situations where this works, and the few situations where sine and cosine have the exact same value. So that would be pi over 4 and not really anywhere else. Let's try tangent. The original graph does not pass the horizontal line test. When we try and find the inverse, it will not pass the vertical line test unless we restrict the domain. We need all the positive y values and all the negative y values. So when we restrict the domain, we'll work from minus pi over 2 to pi over 2. I'm going to graph the inverse. Let's find some key points. At minus pi over 2, the y value looks like it's approaching minus infinity. So that will be minus infinity minus pi over 2. 0, 0, stay at 0, 0. At pi over 2, looks like we're going to infinity. So that will be the point infinity pi over 2. Check your graph and see if this is what you get. At minus infinity, we're at minus pi over 2, 0, 0. And at infinity, we're at pi over 2. Again, the graph is not that crucial. I just wanted you to have a picture of what's happening, and this is what matters. Again, this is a great time to try this on your own. You're finding the angles that have a tangent of the given value, and your answers must be between minus pi over 2 and pi over 2. Put me on pause, try them yourself, and then we'll check. We'll check the answers to the first 3. If you need to see the work, tangent is y over x. So the y value is root 3, the x value is 1. This is our 30, 60, 90 triangle, where across from the bigger side, it would be the bigger of the two angles. The angle whose tangent is 1 over root 3, tangent y over x. 30, 60, 90 triangle again, where across from the smaller side, the smaller of the two angles. The angle whose tangent is 1. Y over x is 1. That's our 1, 1 root 2 triangle. So the angle is pi over 4. 3 more to try. The angle whose tangent is 0, and the angle whose tangent is minus 1 over root 3. We drew the unit circle for this one. Tangent y over x, so we really need a y value 0. That happens at 0. Tangent minus 1 over root 3, y over x. This is a negative angle. It's across from the smallest side, so it's the negative of the smaller angles. The inverse tangent of the sine, don't even think about it. You're going to have to work that out. We cannot just cancel those out. Sine of minus pi over 2. We'll draw the angle of minus pi over 2. Sine is y over r. So that gives us a value of negative 1. The angle whose tangent is negative 1. Tangent y over x. And that angle is minus pi over 4. Now you might be asking yourself, how are you supposed to remember which answers you're allowed? What is the domain for each one? And there's a fairly easy way to remember just using the cast rule. What you want is you want to be able to find positive and negative values for sine, cosine, and tangent. And you're looking for the simplest answer possible. So let's look at sine first. Positive values in here, those are the simplest ones, they're the smallest. Then we need some negatives. We have a choice of this quadrant or this quadrant. Of the two, these answers are smaller, so we'll pick that one. also it's connected. If we picked this quadrant and this quadrant, they'd be disconnected, and that really doesn't make much sense. So sine values will go from minus pi over 2 to pi over 2. See if you can figure out cosine on your own. Positive cosine values in this quadrant. Negative ones, your choice is this quadrant or this one. We like the continuous one, so we go from 0 to pi. Tangent, a little more tricky. Positive values, negative values could be in either of those two quadrants. There's a bit of an argument for either one, and we're picking minus pi over 2 to pi over 2. The reason for that is from the original graph. Between minus pi over 2 and pi over 2, this is a continuous function. If we had picked these two quadrants, you would have been working with this part of the graph and this part of the graph. And there's an asymptote between those two. So mathematicians like to pick the one that was continuous, and that's the reason that tangent goes from minus pi over 2 to pi over 2. Okay, last examples before you get to work on your own. Find an exact value for the sine of the inverse cos of minus 1 over root 2. Start from the inside out. What angle has a cosine of minus 1 over 2? Cosine x over r. So we have some angle with a cosine of minus 1 over 2. So we're going to find the sine of that angle. Sine is y over r, and we recognize this triangle, so the y value is root 3. We can now write down the sine as root 3 over 2. Sine of the inverse tangent of 3 over 4, start from the inside. Tangent y over x, so there's some angle that has a tangent of 3 over 4. We're going to find the sine of that angle. Sine is y over r. Now this is not one of the triangles that you know. But we have a right angle triangle, we know two sides. We could use Pythagoras to find the other side. 3 squared plus 4 squared is 25. So c could equal plus 5 or minus 5. If we look at the picture, that's a radius. Those are always positive. So c is 5. We can now find sine. Sine is y over r. So our answer is 3 over 5. Try these two on your own. Put me on pause. Check your answer in a moment. Checking your answer, the angle whose sine is minus 5 over 13. Sine y over r. There's some angle with a sine of minus 5 over 13, and we're going to calculate the cosine of that angle. So again, what we did, we said there's some angle that has a sine of minus 5 over 13. We call the angle A. So we're just replacing this with A. Find the cosine of that angle. Cosine will be x over r. We just need the x value. It's not one of our special triangles, so we use Pythagoras. Plug in your x value and your r value. We'll find out that the other side squared is 144. So a could be 12 or minus 12. And according to the picture, we're on the positive x-axis, so it would have to be positive 12. Cosine x over r. Final answer, 12 over 13. This one, the inverse sine of the sine of pi over 4. If you do it the long way, sine of pi over 4, 1 over root 2. The angle whose sine is 1 over root 2, pi over 4. If you do it the quick way, the inverse sine will cancel out the sine. They undo each other. The answer is pi over 4. And we said that works most of the time. When doesn't it? Let's look at these two examples. We'll do it the long way just to see what's happening. Sine of 3 pi over 4. Our angle of 3 pi over 4 leaves an angle of pi over 4 in here. The sides 1, 1, and root 2. So the sine of 3 pi over 4, y over r, is 1 over root 2. You're now asking yourself, what angle has a sine ratio of 1 over root 2? This one does. But there's another answer. The other answer is pi over 4. And why did we pick that one and not this one? When you're finding an answer for the inverse sine, it has to be between minus pi over 2 and pi over 2. So when we restricted the domains, we said the answers for inverse sine must lie between minus pi over 2 and pi over 2. So another way of thinking of this question, these really undo each other, but you're saying, what angles have sine values in common? So 3 pi over 4, similar to the angle over here, pi over 4. They have the same ratios in terms of y and r. We're going to try that idea with this one. Sine of 11 pi over 7. 11 pi over 7 is somewhere down here. We're not allowed 11 pi over 7 as an answer because it's not between minus pi over 2 and pi over 2. 11 pi over 7 is this one. So is there another way of describing this one, going from minus pi over 2 to pi over 2? If we think of it that way, how far is 11 pi over 7 from 2 pi? So what is the equivalent of 11 pi over 7 in this domain? It's minus 3 pi over 7. How did we do that? 2 pi minus 11 pi over 7. 2 pi is 14 pi over 7 minus 11 pi over 7 is minus 3 pi over 7. So you don't need to figure out the sides for that. You know they undo each other. You just have to make sure when you find your answer, it's the equivalent in this domain. Your job today, you're working on page 2 and 3. You're doing 1 to 5. If you have any questions, let me know.